Here's your continuation rewritten into a seamless, flowing narrative without headings or hashes, keeping the same cinematic tone. It's fluid. It's alive in a way no gas giant has ever been described. The fact that such a material could exist naturally, thriving in the heart of a world billions of miles from the Sun, forces us to reimagine what planetary interiors can be. This may not just be a new discovery, it could be the birth of a new class of planetary behavior. One defined not by rigid structure, but by interaction, transformation, and constant energetic motion. In every textbook, planetary weather is explained as the result of energy input from a star, sunlight striking an atmosphere, driving winds, currents, and storms. But Neptune refuses to follow those rules. At nearly 4.5 billion kilometers from the Sun, it receives less than 1/1900th of the solar energy Earth gets. And yet, it boasts the fastest winds in the solar system. How? The James Webb Space Telescope has now collected enough evidence to support a radical hypothesis. Neptune's weather may be generated entirely from within. Neil deGrasse Tyson described a world that feeds its own storms, where thermal pulses erupt from deep within, bursting upward through the atmosphere and driving immense turbulence, vortexes, and cyclones from the core outward. These aren't gentle winds stirred by sunlight. They are superstorms powered by the restless chemistry and shifting entropy of Neptune's underlayers. If confirmed, Neptune would become the first known world with a climate system independent of its star. A self-sustaining atmospheric engine fueled not by light, but by its own internal furnace. This changes everything because if weather can arise without sunlight, then worlds far from any star could still be dynamic, active, and perhaps even habitable in ways we've never imagined. The shockwaves from this revelation don't stop at our solar system. Tyson warned that if Neptune defies our models, then so might the thousands of similar exoplanets we've already discovered, mini-Neptunes and sub-Neptunes orbiting distant suns. These planets have been studied, classified, and ranked for potential habitability using the same assumptions that Neptune has just shattered. If its heat comes from exotic matter instead of radioactive decay, if its magnetic field is shaped by superionic ice rather than a molten metallic core, if its storms are powered from within instead of from starlight, then countless worlds we've already catalogued may be far more alive and complex than we dared to think. In his closing moments on stage, Tyson offered a possibility that silenced the room. What if Neptune isn't a planet in the traditional sense at all? With its ability to generate heat, harbor exotic matter, produce magnetic anomalies, and emit strange radio patterns, it might exist in a gray zone between planet and failed star. It doesn't have the mass for nuclear fusion, the hallmark of a star, but its chaotic energy and unexplained temperature suggest processes far beyond ordinary planetary physics. Some theorists are beginning to call it a transitional object, a relic from an earlier era of the solar system, a fragment of a process we no longer see. Perhaps it is the frozen echo of a protostar that never ignited, or the captured remains of a wandering planet reshaped by the sun's gravity. Whatever it is, Neptune is tearing down the categories we once thought were unshakable. It refuses neat labels. It defies the symmetry of known planetary behavior. Its magnetic chaos, exotic chemistry, and unpredictable interior paint the portrait of a world in rebellion against the very physics we believed governed the cosmos. If Neptune can be hollow, dynamic, self-powered, and something between a planet and a star, how many other worlds have we misjudged under the same flawed rules? Neptune was once a distant afterthought, a cold dot on astronomy charts. But now, thanks to Webb's deep gaze and Tyson's bold interpretations, it stands as a monument to mystery, a reminder that beneath the surface of what we think we know lies an ocean of unknowns. The James Webb Space Telescope didn't just observe Neptune, it listened to it. It caught its hum, decoded its pulse, and revealed a truth that should shake every assumption we've made about the universe. The cosmos is stranger, louder, and more alive than we ever dared to believe. So if you thought you knew Neptune, think again. The question now isn't whether it's a planet, a failed star, or something else entirely, it's whether we're ready to accept that the universe holds objects for which we don't yet have names. Because Neptune has spoken. And it's not finished. Here's your Neptune script rewritten into a smooth, continuous narrative without headings or hashes, keeping the suspenseful tone intact. For decades, Neptune was seen as little more than a frozen, silent sphere drifting at the far edge of our solar system. A pale blue world locked in a cold, uneventful orbit. But something has changed. The James Webb Space Telescope has pierced through Neptune's cloudy veil, and what it revealed challenges everything we thought we knew. When Neil deGrasse Tyson addressed a global symposium about these findings, he didn't just share data, he sent shockwaves through the scientific community, hinting that Neptune might be far stranger than anyone imagined. Neptune was never discovered through a telescope in the traditional way. It was first predicted through mathematics, its presence revealed by unexplained wobbles in Uranus's orbit. When it was finally observed in 1846, astronomers classified it as the eighth planet, a frigid gas and ice giant spinning far from the Sun's warmth. Voyager 2's 1989 flyby offered only brief glimpses of its fierce winds and swirling storms. After that, Neptune was largely ignored, filed away in astronomy's archives as a cold anomaly in a distant corner of the solar system. But beneath those tranquil blue clouds, something has been stirring, waiting to be found. Webb's infrared vision, combined with advanced Earth-based radio arrays, now reveals that Neptune does not behave like a conventional planet. Its interior is not neatly layered in predictable shells of ice, gas, and core. Instead, it appears to be a chaotic, shifting mosaic, zones of slushy plasma, regions emitting unexplained heat, and pockets deep below the cloud tops radiating thermal energy with no clear source. With no nearby moons to create tidal heating and too little sunlight to explain such warmth, the cause remains a mystery. Even stranger is the possibility that Neptune may be partially hollow, containing resonant chambers that trap and reflect electromagnetic and gravitational waves, as though the planet itself is humming a cosmic note. Tyson described a restless, unpredictable world where our classic models of planetary structure collapse entirely. One of the most startling revelations lies in Neptune's magnetic field. Long known to be tilted and offset, it is now observed to be changing in real time, drifting, breaking apart, and reforming in unpredictable cycles. This could be the work of exotic materials buried deep within. Scientists suspect a layer of superionic ice, an electrified form of water that is part solid, part liquid, flowing under immense pressure and generating magnetism in a completely alien way. Instead of a molten metallic core like Earth's, Neptune's magnetic engine may be chemical rather than mechanical, powered by charged hydrogen moving through a frozen oxygen lattice like lightning through ice. As if that weren't enough, Webb has detected unusual radio signals from deep within the planet. These are not the expected emissions from solar-wind interactions, but strange, low-frequency patterns unlike anything in known atmospheric physics. Some theorize they may be the signature of quantum-level processes occurring inside Neptune's core, phenomena that defy classical science. Others wonder if they hint at unknown states of matter, existing only under the crushing pressures and bizarre chemistry unique to this world. Neptune's storms, with winds over 1,300 miles per hour, may not be driven by sunlight at all, but by pulses of heat from within. In many ways, its interior behaves less like a planet and more like a failed star, a body trapped in a state of endless instability. Hidden within its depths could be vast internal circuits of exotic ice, channeling electrical energy, shaping its storms, and feeding a magnetic field unlike anything else in the solar system. What James Webb has uncovered forces us to ask uncomfortable questions. If Neptune can break every rule of planetary science, how many other worlds, both near and far, might be playing by rules we haven't even discovered yet? The planet once thought to be a quiet, frozen giant may turn out to be one of the most active, complex, and mysterious worlds we've ever encountered.